Okay, hello everyone. We can start. And let's start with a question. How do you upgrade a critical system without anyone noticing? That's the talk that we are gonna cover this time. It is a journey to zero downtime upgrades with Keycloak. Keycloak is used by hundreds or thousands of organizations managing identity and access. If such a service managing the identity and access is down, the downtime is not just annoying, it's just critical for your business. In this talk, we will talk about how we are moving forward towards the zero downtime upgrades in Keycloak. And we will see what's new inside there, what's next, and what works. Before we go deep inside, it would be nice to introduce ourselves, right? So I'm Martin Bartoš, and I'm Senior Software Engineer at IBM, and I'm part of Keycloak Cloud Native team.
Hi everyone, I'm Ryan Emerson. I'm a Principal Software Engineer at IBM, and I'm part of the SRE team.
Yeah, so before we go down into the zero downtime upgrades and so on, it would be nice to say some words about Keycloak itself. So, what is actually Keycloak? Keycloak is Identity and Access Management Solution, or IAM for short. It authenticates and authorizes users for services. Keycloak handles logins, token issuance, and even request validation for your applications and APIs. There's the question, do you really need an IAM in your deployment? The answer is simple. Yes, you do. Sometimes there are some companies or organizations, they want to do the authentication and IAM on their own, but sooner or later they find out it's a rabbit hole. You know, you can cover the basic stuff like logins or sessions, but then there are some requirements about token standardization, about user federation, about security edge cases, security CVEs, even multi-factor authentication, and so on. But Keycloak takes care of everything like that, so you can focus on your business needs. So, Keycloak authenticate and authorize users and services, plus offers the single sign-on capability, which means that your users can only log in once across your organization. Keycloak provides the bridge to existing infrastructure, so you can connect it with the Active Directory, LDAP, even with your own database of users. Also connect it with any other OIDC, SAML, or Kerberos provider, and your users can log in also via social providers like Google, GitHub, Facebook, and so on. Keycloak run and scale in cloud and non-cloud environments, and we offer Kubernetes operator and high availability setups. With the recent release, we provide passwordless authentication, so you don't need passwords anymore. So you can use security keys or biometrics, for example, Face ID, and so on. It would be nice to mention something about Keycloak in numbers, because it's quite interesting. Last month, we've reached 30,000 stars on GitHub, which is quite, yeah, thank you, which is quite nice indicator how Keycloak is valued in community and how it's trusted. We have more than 1,300 contributors, and project started on 2013, and we've become a CNCF incubating project since 2023. Yeah, we can cover if it's, it's maintainer's talk, so we can cover even the most recent release, which is Keycloak 26.4, sorry. And on the QR code there, you can find all the changelog there's available. So, but some highlights, there are the passkeys integration for the passwordless authentication. There's the support for financial grade API version 2. There's the depop support as demonstrating proof of possession, and preview support for federated client authentication like SPIFFE. There has been improvements even for multi-availability zone Kubernetes deployments, and there's many more features and bug fixes and so on. Yeah, but the main question remains unanswered, right? So this is the zero downtime, and Ryan tell you more about that. Yeah.
Okay, thank you, Martin. So why should you care about zero downtime rolling updates? Well, in general, service downtime is considered a bad thing. However, in the case of Keycloak, it is a critical component of many organizations' infrastructure. If Keycloak goes down, then user and client requests can't proceed, so business workflows are going to be interrupted, and you're going to have severe knock-on effects. So as a consequence of this, what we typically see is upgrades and configuration changes to Keycloak deployments are restricted to planned maintenance windows, which is a good tactic. It makes sense in general. But the fact that we require complete downtime means it's often very difficult to schedule that in the real business world, because when does your business stop? And as a consequence of that, things like CVE fixes can be delayed when they're being rolled out, which security is paramount. You don't want to be delaying CVE fixes. So our solution to this is to leverage rolling updates, which I'm sure is a concept many of you are familiar with. But the basic idea is that Keycloak upgrades or configuration changes can be performed while continuing to serve user and client requests. The idea is that instances of Keycloak are replaced one at a time, and as a consequence, there's at least one Keycloak instance ready to handle these user and client requests. However, it's a nice idea, but there are many challenges. In the case of Keycloak, not all configuration changes are compatible. So to give an example, if you change the clustering stack from TCP to UDP, during a rolling update, the cluster's not going to form as expected, and you'll get a split brain scenario. Similarly, Keycloak in the past has provided no guarantees about version compatibility when used in this kind of mixed cluster mode. And so the bigger the distance between your Keycloak versions, the more likely you are going to get incompatibilities. Something like a Keycloak major upgrade being used in a rolling update, it's not going to go well, most likely. So one does not simply roll out a stateful set. We need a solution that helps us determine if a rolling update is safe, and only if it is safe should we perform it. So for this solution, we have a few different requirements. Or we had requirements. We have solved it, spoiler alert. It should work on both bare metal and Kubernetes deployments. It needs to be fully automatable by our operator. And it must support custom Keycloak images. Typically, we see people extending out base images to add custom themes to providers, that kind of thing. So it's crucial that works with any solution. But the most important things are, if we're aware of an incompatible configuration change, we should be able to reject rolling updates. And similarly, if we know there's an incompatible Keycloak version, we shouldn't allow a rolling update there either. Now, the problem of Keycloak versions is really the hard one. And so for our initial solution, we're limiting our solution to only focus on allowing the rolling update of Keycloak patch releases. So 26.5.0 to 26.5.1, that kind of thing. So they were our requirements. I'll now walk through the solution that we came up with and then how we automated that within our operator. So the foundation of our solution is a Java interface, which is called the compatibility metadata provider. The idea is that implementations of this interface generate and verify metadata to determine if rolling updates are possible in a safe way. Within Keycloak, we have multiple implementations of this interface based around Keycloak functionality. So we have one for the database layer, one for the caching layer, etc. This is part of the SPI, so extensions can implement their own version of this interface and if they want to be rolling update compatible. So that's the foundation. We then expose this to users using a new command. This new command is the update compatibility command, and this is executed against the Keycloak launcher script kc.sh. So this is a completely standalone command. It's stateless. You don't need a running Keycloak server. And within this, we have two subcommands. The first one is the metadata subcommand. And the purpose of this is to generate the metadata that we'll use to verify compatibility. The first argument it takes is a file argument, which is where the metadata will be written to. In this case, temp/kubecon./JSON or .json. And the idea is that you specify your entire Keycloak configuration to this command. So in this case, we have a simple configuration that just enables the spiffy feature. And by providing the same CLI options that you use to launch a server to this command, you generate metadata that is representative of your actual deployment. So we execute this command and we store some metadata. The then follow-up command to this is the check subcommand. And what you do here is you specify the metadata file that you wrote in step 1, and then you change your configuration to what you want your deployment to turn into. So the example on the slide at the moment is we now have the spiffy feature as before, but we also have the Kubernetes service account feature. So we go ahead and we execute this command, and it will check all of the compatibility metadata provider implementations to ensure that the metadata is compatible. If it is compatible, then we'll get a message saying rolling update is available, and we'll get a status code of 0. However, if there is an incompatibility, we'll get a status code of 3 and some appropriate error messages that helps tell you why it's incompatible. So that's how you check if a configuration change is compatible with a rolling update. However, if you then consider Keycloak version upgrades, what you do is you execute the metadata command using the old Keycloak version, and you execute the check command using the new Keycloak version. So by using status codes and things here, the idea is that you can do this manually, or you can incorporate it as part of your pipelines and custom automation. One second. So that's our kind of the base solution we come up with. We then need a way to automate this within our operator. So what we have here is a Keycloak CR, and this is used to create a Keycloak cluster. The important thing for this demo, though, is that in the specification, we have added that we want the update strategy auto. And from a high level, this means if a rolling update is safe on a configuration change or an upgrade, then we will do a stateful set rolling upgrade. If it's not safe, we revert to the operator's old behavior, which is we recreate the Keycloak cluster from scratch. So I'll now walk through an example of how this works. We apply the CR that was on the previous slide. The Keycloak operator reconciles this and provisions your Keycloak cluster. However, we then decide that we want to change the configuration. We go from using the login v1 feature to the login v2 feature. The operator detects this change, and it then provisions a Kubernetes job. Within this Kubernetes job, we have two containers. The first container executes the metadata command, and it does so using the configuration of the existing Keycloak cluster, and it does this using the container image associated with said cluster. The second container then is a regular container that consumes the metadata written by the init container, and it executes the check subcommand using the latest configuration as updated in the Keycloak CR. So here we can see on the slide we have login v2, and it also executes this using the latest container image if you happen to change the image. So when that completes, the operator checks the status code. If the status code is 0, a rolling update is possible. We do a stateful set rolling update. If it's not possible, then we recreate the stateful set by deleting the original one and creating a new one. So that's how we automate things. The idea is not just to blindly do this into production. We would expect people to try it on their dev clusters first and also utilize the commands, maybe in isolation, so they know what behavior to expect. If a rolling update is possible, great, they can plan for that. If it's not possible, then they're back to the old solution, which is requiring downtime. And unfortunately, that's not always avoidable. So that's how the solution we came up with and how we operate it, how we automate it in our operator. Unfortunately, the challenge doesn't end there. Arguably, the hardest part now is how do we ensure that different Keycloak versions work together in a rolling update scenario where you have a mixed cluster of different Keycloak versions. Well, there's a number of challenges here. Ensuring clustering communication, making sure that database schema changes don't break things, and on a project level, how do we test things to an extent that we're comfortable with these guarantees? So first up is clustering. I would say this is probably the hardest problem. We use InfiniSpan to form Keycloak clusters, and InfiniSpan is a distributed caching solution. It's used to invalidate the local Keycloak caches and maintain a shared state between the Keycloak pods. The challenge, though, is Keycloak can introduce new InfiniSpan versions within the Keycloak patch stream. So we need to make sure that these distinct InfiniSpan versions can also communicate as expected, so the cluster forms and continues to work. So that's the challenge. Unfortunately, InfiniSpan really didn't make our life easier here. In the past, the serialization layer was written using handwritten Java marshaller classes, which was very performant. However, there was absolutely no tooling to check compatibility between different InfiniSpan versions, and compatibility was broken in the past. And to make this worse, these incompatibilities were only detected once InfiniSpan had been released, once Keycloak had consumed the InfiniSpan release, and then once Keycloak had been released. So it was far too late in the process. So we needed a major refactoring of the InfiniSpan library. Starting with InfiniSpan 16, which was literally released last Friday, we now utilize protobuf. InfiniSpan now utilizes protobuf-based serialization. This allows schema evolution over time. You can add new fields to messages, that kind of thing. And crucially, allows the verification of message compatibility at build time. So before an InfiniSpan PR even gets accepted, we know whether compatibility has been broken or not. The InfiniSpan team also spent a hell of a long time developing a new test suite that ensures compatibility across different InfiniSpan versions, and this is incorporated into their CI processes. So, yeah. Then the next challenge is database schema changes. Newer Keycloak versions may require changes to the database schema. However, things like new index creation can be problematic because it potentially can lock the database, which again, in a rolling update scenario is problematic because we're trying to avoid downtime, but if you lock other Keycloak pods from accessing the database, you effectively have downtime. So our solution here is not a technical one. It's more of a project kind of limitation we're imposing on ourselves. We're saying for Keycloak patch releases, we're not going to allow changes to the database schema. The exceptions being CVE-related or critical bug fixes. This limitation isn't ideal, but based upon past patch release streams, we think it's acceptable and shouldn't pose too many problems. However, we are working on tooling to detect these kind of incompatible schema changes. And in the future, we are going to need a more robust solution because we want to ideally support zero-downtime upgrade of minor releases, or who knows, go for the moon, major upgrades, but we'll see. Finally then, testing compatibility. For those familiar with Keycloak's old test framework, it was based on Archillion. It was not very flexible is the nice way of putting it. The new framework here has made things much easier. And as part of this new test framework, we've come up with a way that allows clusters to be formed using distinct Keycloak versions and then tests executed against those clusters. So we already have some OIDC workflow tests in place. We're going to continue to add more tests over time. And the idea is, again, our CI is going to automate all of this and execute the tests against a a matrix of different Keycloak versions. So we know when pull requests come up to a high degree of confidence that compatibility is maintained. So what's the current status of this feature? Well, from 26.4, rolling updates of configuration changes is fully supported. Keycloak patch version upgrades is only in preview support, and the reason for that is we're waiting to upgrade to InfiniSpan 16. Like, it was only released on Friday, so give us some time there. We're also continuing to evolve the database schema tooling that I mentioned before. But most importantly, we would like more user feedback on this feature. So if you guys can read the documentation, try it out, let us know what you think on GitHub issues, Slack. The more feedback we can get, the better, and hopefully the feature will continue to evolve. I'll now hand back to Martin.
Yeah, sure. So along the way, we've learned a few key lessons. Give me that, thank you. The first one is that ensuring cultural buy-in, as zero downtime is not just a technical term, but it needs to be a team mindset and a project priority, and it's ongoing endeavor. Right. The second one is automating the tests. Manual processes do not scale, and people basically forget. Right. It ensures the consistency and confidence in this. And the last one is leveraging existing solutions to do the heavy lifting, so not reinventing the wheel again and just rely on this. Yeah, right. So get back to Keycloak, right, itself. What are the future plans for Keycloak? What is on our roadmap? The first thing is the zero downtime upgrades is fully supported, then improving horizontal scalability, Kubernetes native databases and support for client CRs, then full open telemetry support for our observability stack, and full support for SPIFFE. There are plans also improving some standardization about scheme or OpenID for verifiable credential issuance, and there's a new feature, Keycloak workflows, that we are working on, right? And there's many more around that, so keep it updated, right? And I think that's it from our side. Thank you for your attention. I hope you learned a little bit about Keycloak, about how we do the zero downtime and stuff. Yeah, and feel free to reach out to us if you have any more questions and so on. And it would be great if you could find some time to fill out the talk feedback that could improve our future sessions, right? So thank you very much. And if you have any questions, here's the mic. You can use it. And if you have even more questions, you can visit us in our Keycloak kiosk that we have in Project Pavilion, right? Yeah.
Yeah, we'll be there till 2 o'clock tomorrow, I think.
Yes.
Yeah.
I got a quick question. Are you guys going to standardize a Helm chart or something for like a quick deployment, or how is that going to look?
Helm charts is something that's often gets asked about. I think a lot of people in the community were using the Bitnami one, which is...
Yeah, I don't want to talk about that. That hurt bad.
Yeah, so there's ongoing discussions. We don't have any concrete plans that I can commit to right now, but we will definitely relay that back as part of our trip report. And
okay, so second follow-up. You had that YAML there that was talking about that autoscale. Is that going to be just another CRD that lives in the K8s cluster, or where does that live?
So the YAML there was part of the Keycloak CR that already exists if you use our operator.
Okay, got it.
Yeah, so there's basically, we've added a couple of different elements. It's the update and then the strategy kind of sub-element, and that configures what behavior you see.
Okay.
I only talked about the auto strategy there, but we have a couple of different ones that actually give you a bit more control with doing less magic. So there's a few things documented there.
Cool, we'll keep it up. It's been great.
Thanks.
Yeah.
A practical use case here, very old version of Keycloak, like single digit. Yeah, so obviously a great path here would be complicated, but will there be a way to copy over at least a part of the database where, let's say, password will be stored with the users and just keep maybe the hashing algorithm possible to use back in the latest version?
I think our story around upgrades, especially if you're on a single-digit version of Keycloak, is unfortunately you're probably going to have to go version at a time, and we are now on 26.4.
Yeah.
So
We did try that with some success, and we also ran on into an issue where, or specific realm being synced with LDAP, the API call would be very slow for those users.
okay.
So is that something noted or that you've experienced?
I haven't personally, but maybe this would be a good chat for us to have at the Project Pavilion, and we can write some details down. And we're not part of the Keycloak core team, but we can put you in touch with somebody who is. So maybe we can get you some help there.
Okay, thank you very much.
Great presentation. I just have one question. So since Keycloak is clustered and has shared state, how do you manage multi-tenancy, and when multiple operators need to be upgraded, how do you ensure there are no upgrade conflicts between tenants?
With the operator, a limitation is the fact that the CIDs are cluster scoped. So from with Red Hat and IBM, in general, the rule is you just have a cluster-wide operator. I think things have improved slightly with OLM v1 for managing that, but honestly, I've not looked into migrating to v1 yet, so I don't really know. Is that my answer?
Yeah, I don't have anything to add.
Thank you.
Okay, there's another question, or are you leaving?
All right. It's great, fantastic. I love it. I have about 3 questions or 4, right? Hopefully it's not too much for you guys. I believe you guys are smart guys and everything. But first question, right? I believe you already answered it for the database schemer. So every time they do an upgrade, it changes the database build number, right? Is that 26 has it or 25 has something like that?
So is the question, sorry, that is there like a build for specific kind of identifier in the database layer?
Yes, so that question will roll into the follow-up question for it. But basically, if you did an upgrade, right, the database build number changes, right? If you roll it back, that database build number will not change. How are you fixing that?
It's a good question. Don't have an answer for you right now.
Yeah, generally a rollback is very difficult in Keycloak, right? And it's recommended to run the new version in some stage environment elsewhere, right? Trying to out if it's all right, but not, right?
Okay. So that also answers my follow-up question to that question. That was about a blue-green deployment. How do you basically do a blue-green deployment, or is there like a standard way of you guys doing a blue-green deployment already?
So blue-green deployments are very tricky with the way Keycloak's clustering works. So in general, it's not something we really advocate for. We don't have a story around that. I'm part of the SRE team, and it's something that's come up a few times and something we do need a better solution for.
Yeah.
But nothing I can detail right now, unfortunately.
No worries. One more question. I hope it's one more. But all right. So I'm using Keycloak everywhere, right? On all my apps, right? I am using, let's say, for example, Confluence, right? I'm deploying Confluence on my own, and I'm using Keycloak for it, right? I'm trying to go into Confluence and disable users who hasn't logged in for the past 90 days, right? That way, I am trying to have an API to call in Keycloak because it's in the database, right? But I could see everything. But inside the database, it doesn't really specify the last login within those applications, right? So basically, if there are sections of these users are in Keycloak, how can I use an API call to call in the specific client of Keycloak, right, about the last logins?
I don't know if we have something or I don't know if I understood the question. Like you need to find out the information about the client itself, or like the status on your application.
So basically, just more like, how do I look at all the last logins to the API call for all the users that has login in the set in a client like today?
I think we don't. There's no way how to do it right now. But it would be great if you could create GitHub issue with the enhancement.
Okay.
Yeah, as we are always trying to get more and more feedback, and we simply cannot cover everything. So if it's needed to community, we would be happy to provide it to you. Yeah.
And at the moment, there is a major refactoring of like the client API, the RESTful side of things. So it would be a good time to get that request in, because it might be incorporated as part of that work.
Okay. All right. Awesome.
Yeah.
Thank you.
Thanks for the very good questions as well.
No worries. Thank you.
Thank you very much. And if you have any more questions, we can find us in the project pavilion. Thank you very much.
Thanks.